So this first one up here, we've got tons, and we're going to convert that over into, eventually turn that into kilograms. And while technically this isn't, the tons is a measurement of weight, and grams is a measurement of mass, since we're staying on Earth and we have the right conversions, it doesn't really matter. So it'll work out for us. So we're going to start off with what we were given. So this 2.34 tons, and we're going to, really? What are you doing? Divided by yards cubed. What kind of unit is this? Yards, or tons divided by cubic yards is a density unit. I've got a bunch of stuff, and then I got a volume for that stuff. Who would use tons and cubic yards?
Miners.
Yeah, so you pull up a bucket of dirt with a big, I don't even know what those things are called. What are those things called? Backhoe? Sure. One of those backhoes that's got the big scoop on it, and then they dump that into something. Well, they know how large the bucket on the backhoe is, and if they drop that on a scale, then now they know the number of pounds or tons or whatever it is for that dirt, and they can quickly determine what the density of that dirt is. And if it's high density, what did we say why would they be happy about that? Some kind of metals in it, maybe gold, maybe copper, maybe iron, maybe who knows what. But it would be normal, more than just what organic matter would be, which is the rest of the soil. Okay, so I'm going to take this tons and cubic yards, and I need to convert that over into grams and centimeter cubed. So how do I get out of tons and closer to grams? Yeah, so if I put ton down here, I can put pound up here, and then I can put one of these, and how many? 2,000. Okay. So we'll cross off tons. And I didn't give you that unit conversion just because I assumed you'd look it up. And then I did give you this pounds and kilograms. So there are 2.2 pounds and 1 kilogram. And then I can go with 1 kilogram gives me 1,000 grams. All right, so I have my gram unit, and I have it where I want in the numerator. I need to get rid of that cubic yard and turn it into cubic centimeters. So we did something similar to this Monday when we went over that gold explanation to figure out what the weight of one of those gold bars were. I'm going to do it a little bit differently this time. So I want to go from yards, and I need to get to centimeters. So what do you want to convert the yards into first?
3.
So if I put yards here and I put inches here, what's that going to do for me? Yeah, let's do that first. 1 and 36. But what's that going to do for me?
It's going to give you a yard to the second power.
So that the 3 yards that are in the denominator, one of them is going to cancel out. Okay? So I can do this exact thing right here 3 times. Or I can put it all together. So if I say this is cubic yards, then I have to cube everything else in this fraction. So I got to cube this 1, which really doesn't do anything since it's 1. But then I can cube this inches, and I can cube this 36. And so now I've got yards that are cubed, and I've got inches that are cubed. Okay, so let's do that again. I put inches up here, and I put centimeters down here, and I can put 1 there and 2.54 here. And then I'll cube the inches and the 1 and the centimeters cubed and the 2.54, and then my inches are canceled. And then I'm left with grams, centimeters cubed. So I just need to be careful when I do the calculation for what I need to be careful about.
Making sure that you're putting those numbers that have powers to them. You're calculating that.
Yeah, so I need to make sure that I've got that 36 cubed and that 2.54 cubed. If I don't do that, then I'm going to be off by a significant amount. The number is going to be way too big. So I'm going to take the 2.34 times 2,000 times 1,000 divided by 2.2 divided by 36 cubed divided by 2.54 cubed equals, I got 2.78. Are we good with that? Anybody have any questions about how I did that?
Well, is that 13 next to the cube?
It's 1 cubed.
1 cube.
I cubed this yard, and since I cubed this yard, I have to cube everything else, all the units and all the numbers that are in this little fraction. So, cubed yards, 1 cubed, 36 cubed, inches cubed. When I write 1 cubed, yards cubed, 36 cubed, inches cubed, what's that equal to? 1 yard divided by 36 inches. 1 yard divided by 36 inches. 1 yard divided by 36 inches. So can you see why I'd rather just do it all in one shot instead of having to write that fraction up there 3 times? All right. We're going to rearrange this and solve for temperature final. Okay. So what should I do first? Or not temperature final, sorry, temperature Fahrenheit. Okay, so I'm gonna 9/5 this, cancel that out. I'm gonna 9/5, I don't know what that is about, 9/5 this. So I'll get 9/5 temperature Celsius is equal to temperature Fahrenheit minus 32. So then I'll add 32 over here, and I'll add 32 over here, and so I get temperature Fahrenheit is equal to 9/5 temperature Celsius plus 32. Okay. I'm going to go from 100 Fahrenheit into Celsius and into Kelvin. All right. So I'm going to take my temperature Celsius is equal to 100 minus 32 times 5/9. Why do I need parentheses here? I need to do that subtraction off the 100. The 32 needs to come off the 100. Without the parentheses, what would the calculator do?
It would do the order of operations and do 32 times 5.
It would do 32 times 5 divided by 9, and whatever that is, then it would subtract from 100. So you definitely need to make sure that this 68 comes out before we do this over here.
Same thing up there, you need parentheses up there.
Don't need the parentheses up there. Why? Because if I put this around that, that was going to happen first anyway. Okay, so I get 68 times 5 divided by 9. I should put degrees Fahrenheit here. And so then I get 68 times 5 divided by 9 equals, cool, equals, I got 37.77 repeating degrees C. All right, so what's my answer for the degree C portion? Why is that my answer?
Sure, rounding up. It has to be 4.
First off, I have 4 sig figs. Is everybody okay with that? How do I know that that 0 is significant?
Because it's there.
It's there. Nobody would have written a 0 there unless there was a 0 there on whatever it was that they were measuring. So it really was 100.0. And I do need to round up because that'll be 37.7777 repeating. So when I look back on that second decimal place, I'll make that an 8. All right, and then how do I get to Kelvin?
At 273.
So I'll take this 3778 and 273, and I'll get a Kelvin here, so I'll get 0.78, and I get, cool. This is really working well today. All right. 013. So then my Kelvin temperature is going to be 310.8. Okay. So what am I going to do with this Kelvin temperature? So if I subtract 273 here, I'm going to get 17 degrees Celsius. So there's my temp Celsius. What kind of temperature is 17 degrees Celsius? Maybe a little chilly of a room. Not a very warm room, but not like exceedingly cold room. Maybe a sweater. So then I'm going to need to do the calculation to turn that Celsius into Fahrenheit. And so then I'm going to use this one that we created in the prior question, the 9/5 TC plus 32. So then I'll take 17 degrees Celsius times 9 divided by 5, and then I'll add 32 to this. And so I will get 17 times 9 divided by 5 plus 32. I get 62.6 degrees Celsius, and so that'll work out to 63 degrees Celsius. Sorry, I wrote Celsius, I meant Fahrenheit. There we go. Are we okay with those? Questions about any of those? No? How about this non-scientific density definition?
How much stuff in space
How much stuff in a space?
in a volume?
In a volume?
How tightly packed something is.
How tightly packed it is. All right, what's the density of a piece of wood with the 240 and 760? Okay, so what units am I looking for?
Grams and milliliters.
I'm looking for a number that's density, right? And so what are the units for density? A mass divided by a volume. So I've got a mass and I've got a volume. So all I need to do is put this together. So my answer has grams divided by, what is it in this case? Centimeters cubed. Okay, so that's easy. I'll just take my 240 grams and I'll divide this by, what is it? 268. 268 centimeters cubed. And what do you get for a value for this? 240 by 268. So I'm seeing 0.895. I have two significant figures. So what answer should I report?
0.90.
And then the answer for will it float is a yeah, because water is 1. So anything less is gonna float. All right, so this next one, I want to know what the final temperature is for a piece of glass that I put 3,750 calories into. All right, so what unit is my answer going to be in? Degrees C. Okay, great. So what I have here is calories, grams, and the fact that I'm looking at glass. So since I'm looking at glass, I can say that the specific heat for the glass is 0.22 calories per gram degrees C. And then what about that 15? That's telling me my initial temperature, right? So I am putting heat into it, but the thing started off at 15 degrees Celsius. All right, so what I'm looking for is a degrees C unit. So the way I would do this problem is I would say 1 gram times degrees C 0.22 calories. That's how I would start my railroad track off. Why? What am I looking for?
Oh, the temperature raising, it always raises by that top amount, right, for 1 gram of liquid.
Correct.
Sure, right, for raising the calorie up.
Yeah. So with this, I get a degree C, and my answer can be in degree C. It's in the numerator, which is where I want it. What do I need to do to get the answer that I'm looking for? Why do I need to add more stuff to this railroad track?
More than just degree C.
This thing that I put in there was degree C's, grams, and calories. I only want degree C, so I use the rest of the information that I have to cancel out the grams and the calories, and then I'll just be left with the only unit that I want. So what do I do? How do I get rid of the grams?
675.
So if I put 675 grams in the denominator, that gram unit's going to disappear. And then if I put 3,750 calories in the numerator, the calorie unit will disappear. And now all I have is a degree C. So 3,750 divided by 0.22, 0.22 divided by 675. And so I get 25.3 degrees C. Am I done?
No.
I'm not.
To add 15 degrees Celsius.
So what we just calculated is in this piece of glass that was this mass, if I put this amount of heat into it, its temperature would go up this much. That's what this is. But its temperature started at 15 degrees Celsius. So I need to take that into account. So I have my 15 here, and so I get 40.3 degrees Celsius. Since I only have 2 significant figures with the 15, then my answer is going to be 40 decimal place degrees C. I didn't use the equation for this. What I need for you to do is think about what's happening in the problem and then get the unit that you're looking for. So that 25.3, I needed you to recognize that that was a change in its temperature and not its actual temperature. If you'd like to use the equation, more power to you, that's fine, go for it. But again, you're not going to see equations with much outside of an actual class. Most of the time, you're just making stuff up on the fly associated with their units. We want to talk about this some more? Everybody good? Okay. So how about this one? I wasn't looking for actual numbers. I just wanted you to tell me how this is going to work out based off of the multiples or the factors with this. So what do I mean by that?
Twice as much and 4 times as much.
Yeah. Okay, so if I'm talking about kinetic energy, right? The kinetic energy is 1/2 mv squared. And so I'm going to look at the kinetic energy of the bug and of the truck. And so they're 1/2 mv squared. 1/2 mv squared. All right, so related to these two things, I can just make the half disappear because it's a half on both sides. So what do I do with the mass number?
Plug it in,
How are they different from each other though?
half.
So this truck is 2 times the mass. If the bug has this m mass, then the truck is whatever that mass is times 2, because we were given the fact that it's 5,000 pounds. Okay, what about the velocity values?
They're the same.
They're exactly the same. So what can I do with the velocity values? So the velocity values disappear, the m's disappear, and then what's the difference between the two? So the truck has double the kinetic energy. Okay, so let's do that same thing over here. So I'm gonna have my bug, I have my truck, and this is 1/2 mv squared, and this is 1/2 mv squared. So I can do the same thing. I can cancel out my half. That can just disappear. Same thing on both. What do I do with the mass? Same thing, right? This truck is twice the mass of the bug. Now what do I do with the velocities? So this bug is 2 times that, but what's different about this? So this this part right here is 2 to the second, 2 to the second. So then this is, over here, my difference is a 4, and over here, all I have is a 2. So which one of these has more kinetic energy? The bug. And how much more does it have? Twice as much. Okay. How about this last one? So it's the calories equal to raising 1 gram of water 1 degree C. What's the actual value then in calories?
40,
1.
100 something.
1. 1. If I put 1 calorie into 1 gram of water, which is about 20 drops, I'm going to raise that 20 drops of water's temperature 1 degree Celsius. Is that a lot of energy? It's not a lot of energy. Okay.